This is Fun with Electronics Project 2, Part 2C. And for this part, we're playing with the light patterns using push buttons to see how they change. So this process was actually fun. I did most of the analysis at home. So starting with trial one, I connected the each individual LED inside of the RGB LED to ground through the push button, seeing um how that would work, and which it failed. There was no effect. There was effect actually. There was effect, but it worked the opposite when I implemented that in the circuit. There was trial two, actually trial two. I implemented the resistors. At the start, it was 400, but then it was 400 in series with the push buttons just for um, just for protection. But then I realized that there was already a 500 ohm resistor, so I combined them. So I combined it to just have 1 kilo ohm of resistance in each path. So here's trial three where I tested almost every case in each of in each of the paths, in each of the LEDs to see what color pattern I could come up with. And all this was done at home. Fortunately, I had um the tools and the components to to do a mini experiment seeing the behavior of an RGB LED. And at the end I came up with an approach. I found two placements that would make a good pattern. So when I press push button number 1, which is connected from VCC, which is 9 volts in this case, to the green LED path, then a pattern which I call it cop mode, activates, which is when the internal red and green LEDs turn on and oscillate. And when push button 2 is pressed, then another pattern comes up, a mode that I call red light, green light, like in the traffic, right, is activated. So it's basically when the blue LED is turned off, but the red and green internal LED oscillates back and forth. And last but not least, another mode pattern comes up, which I call emergency mode, which is basically pressing both buttons, push buttons 1 and 2, which only causes the internal red LED to turn on and off. All right. So here we have the circuit, the overall circuit right here. Sorry, it's a bit blurry. All right. Alright, so for each path, for each internal LED path, I implemented the 1 kilo ohm resistor just to offer more protection for the internal LEDs, which will cost me some of the brightness that it offers, but it's worth it. It's worth it. I talked about this between the drawback of having more protection, but less of the brightness that the LED provides. I talked about it previously in part 2B, I believe. So now here's the hardware. Here's the circuit. So right now it's at its normal blue, purple, and green bluish state. All right. So now when push button 1 is pressed, both the internal red and blue LEDs turn up. They oscillate. So they're oscillating at a very fast rate, as you can see here. All right. And when I press push button 2, both the red and green internal LEDs oscillate. They light up. And this mode is called green light, red light, green light. All right. And last but not least, we have the emergency mode, the emergency pattern. So that occurs when both push buttons are pressed. And here we have the emergency mode where the internal red LED and the RGB LED turns on and off at a very fast rate. Yeah. So here's the graph, just for more visualization. Sorry. All right. Yep. So we can't tell that much by the oscilloscope since this oscilloscope is limited in precision and precision. Sorry. So yeah, so the oscilloscope setup is pretty much the same. The channel 1 is connected to the anode of the red LED, and channel 2 is connected to uh, the blue LED's anode. So yeah, but we could take a look at it. We could look at it visually. So that's what matters. As long as we get a light show. So here we have the first mode, which I call a cop mode. And then here we have the red light, green light mode. And then when I press these two push buttons, emergency mode. Yep. Pretty cool.